Now, let's start. Sets. All right. Now, we will look at set notations. Uh, what do we mean by set notation? That is actually the definitions of sets in different representations. All right, let's have definition one. Set A equals x such that x is an integer. So sometimes you can see this, and what it means is that the elements of this set are integers, the elements of set A. So set A is represented with capital A. Then the members of set A are actually enclosed in set braces. All right? Yes. Now, another definition could be of set B, which is actually like this. You see something like this. All right. So what does this mean? That means look at this. Just look at this. Have a look at this, right? Have a look at I want you to have a look at this in relation to this. Okay? So here we had just x such that x is an integer, right? But here you have a sort of a point, general point like x comma y. It's a coordinate actually. Coordinates like say 2 comma 3, right? They can be plotted. Let's say you have an x and y axis like this. So 2 comma 3 could be if you have 2 here on the x and 3 somewhere here on the y axis. That means this point is somewhere here, all right? Is the point 2 comma 3. Yeah. So that means this set is the set of coordinates that will be plotted to give us a straight line, because this is a general formula for a straight line, all right? Coordinates which when plotted and joined, they will produce a straight line on the axis, all right? So that means this set would, for instance, would look like this. It would be set B, then we have some coordinates in here, all right? Comma, let's say this is 5 comma 7. Okay, it's a coordinate comma. Then we might have 0 comma say 5, all right? Then and so this is a set of coordinates, all right? Don't be confused, all right? Now let's continue and look at this one thing also. Another representation could be set C is the set x, all right, such that let's say a is less or equal to x, which is less or equal to b, all right? So what is this now? What do we have here? Hmm? What do we have here? What do we have here? This is actually an interval, all right? It's basically an interval. Let's see how it looks like. So it means that it is the set of x values which are between a and b. For instance, let's say minus, let's say x is such that minus 4 is less or equal to x, which is less or equal to 4. What does this mean? What does this mean? This means that um, the x values in that set, let's still call it set C, the x values would start from -4, -3, -2, -1, 0, right? 1, 2, 3, 4. All right. So these values are between -4 and 4. So because there is an equal, less or equal, less or equal, that means this 4 is included. All right. It is included. And this one is also included. All right. Now, this is the set, but it is actually the notation of the set is this, but in actual sense, this is how the set is. Now, the last one could be set D, all right, which is say A, B, C, and so on. So this means that the set actually is actually represented in the form of its members or its elements, right? So these are basically the common what? The common notations that are used for sets. In actually here we are in grade 8. This is grade 8 mathematics. So from grade 8 you are actually uh, tutored on how sets are actually represented or are defined in mathematics. All right? Yes. So now let's have a few examples here. Let's have a few examples here. Let's say you had uh, a set W, and it's a set of X, okay, such that X is an and what? X is a natural number. All right, let me do this. Yes. You see this is this almost the same as this, if you could just look at it carefully. W is the set of X such that X is a natural number. That means X is a natural number. This is what it means here. Okay. So natural numbers are counting numbers. We will get to that later. They are counting numbers. That means this set W is actually the set of counting numbers. 1, 2, 3, 4, 5, and so on. All right. It is notated like this, but now this is the exact uh, representation of that set. All right. So that is how we can use set notations to represent sets. So what I would like us to look at now, it's actually the set symbols. All right. Set symbols. So now set symbols, we have this symbol, we have this symbol, this one. So this symbol is actually equal to, it means it's an element of. It's an element of. All right. So what does it mean? If you have, let's say you have uh, a. All right. No, not this one. Not this one. Let's say we have this. X is an element of set A. All right. You have something like this. So it is read X is an element of set A. So this means that you will find this element inside set A is one of the elements in set A. Okay. Now that's what the symbol means. So if you see this under this topic, you know it means it's an element of. X is an element of A, right? So sometimes we will find this. So this is basically is not an element of, is not an element of. Okay? So if we have 2 like this, what does it mean? That means 2 is not an element of set A. That means you do not find 2 inside set A. All right. All right. Good. Now, let's look at this one. This element. A complement, right? A complement. Sometimes it's read A prime, but it's A complement. So what does it mean? It means complement, all right? Complement of of set A. Okay? So what does complement of set A mean? Complement of set A means it implies outside outside set A. All right? Outside set A. So if you see uh, 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 a complement, that means we are going to focus on elements that are found outside set A. Then we will list them. All right? So if you say X is an element of a complement, what do you mean? You mean that X is found outside set A. All right? But here we mean X is found inside set A. Here, X is found outside set A, right? Okay, that's good. Now, that's good. I can feel that it's good also to you. Let's have this one also. There is this symbol. Sometimes we have this. These two, they mean one and the same thing. Okay? They mean one and the same thing. So what do they mean? They mean empty set. They mean empty set, right? Empty set. So if there are no elements inside a set, we represent it like this. We can say A equals to an empty set, all right? Or A is an empty set, just like that. That means it has no elements, right? There are no elements. There are no elements in set A. All right. There is this other notation or symbol rather. What does it mean? Lower capped N of set A. What does it mean? This lower capped N means number of elements. Number of elements in set A. So this means you are going to count the elements in this set and you give that value. Okay? So it means what? What does it mean? Number of elements, number of elements in set A. Number of elements in set A. Let's have for instance, e.g., let's say set A is equal to A, B, C, D, E, F. All right? This is set A. All right? So if you are asked to find n of A, what would you do? N of A. That means number of elements in set A. What do? You are going to count them. You're saying 1, 2, 3, 4, 5, 6. So there are 6 elements. So number of elements in set A equals to 6. Okay? So you count the elements. All right. All right. All right. That is good. That is good. That is good. Now, we still have other symbols to look at. We have this one, the master symbol. All right, this one, the master symbol. It's called universal set. Universal set. Okay, it's the universal set. So the universal set actually it's the set of all the other sets. The universal set is usually drawn as a rectangular set. I'm sorry. I was trying to draw a rectangle here, so it's like this. Usually you will find other sets inside it. Let's say we have set A and set B. They are found inside this rectangular set, which is the universal set. So the universal is the set that contains all the other sets. Okay? Even all the members which will be found outside those sets. We will find examples on this. Now I'm just explaining these things. Now, we have another symbol which you would see A union B, right? So this actually as union of set A and set B. Union of set A and set B. That means we put the elements of set A and set B together. We have this symbol. This is actually intersection of set A and set B. What does this mean? Intersection, the common elements. We talk of the common elements. Elements that appear in both set A and set B. Common elements, all right? Yes. Now, we also have this one, this symbol. Okay? That symbol. What does it mean? This symbol is actually a subset, all right? It is actually A is a subset of B. Okay? So set A is a subset of set B. What does that mean? When we say set A is the subset of set B, what do we mean? We mean that set A is contained in, okay, or equal to set B. Set A is contained in or equal to set B. Okay, that's what this means. Set A is contained into or is equal to set B. All right, we are going to see this clearly when we are doing examples. Now, there is this symbol also, this one. That means set A is not a subset of set B. That means set A is not contained in nor equal to, okay, set B, right? We have this one which is more or less similar but different. This one. What does it mean? It means set A is a proper subset of set B, right? It's a proper subset of set B. So a proper subset means all elements of set A are also members of set B, all right? All elements of set A are also members of set B. All elements of set A are also members of set B. That is a proper subset. So then you can have this one, which is the opposite now. It means all members of set A are not also members of set B. All members of set A are not also members of set B. All right? Yes. Now, having said this, I think we have covered all that I wanted us to cover as uh, according to the objectives of these presentations. We have looked at set notations. That means the different ways set are defined, all right? And we have also looked at set symbols. So this is grade 8 mathematics, all right? Now, until we meet again on this topic, sets, whereby we will now looking at examples and trying to look at the exam-based questions and the prescribed approach as far as what we have discussed is concerned. Good day.